Diodes are used as rectifier circuits to convert AC voltage to DC voltage. Rectifiers are used in all DC power supplies that operates using an AC voltage source.
Rectifiers can be classified into three categories, which is half-wave rectifiers, full-wave rectifiers, and bridge rectifiers. A half-wave rectifier is defined as a type of rectifier that only allows one half cycle of an AC voltage waveform to pass, blocking the other half cycle. Half-wave rectifiers are used to convert AC voltage to the DC voltage and only require a single diode to construct. Diode is connected in series to an AC source and to a load resistor RL, forming a half-wave rectifier. Generally, the AC supply comes from a transformer. The use of a transformer offers two advantages. Firstly, it allows us to step up or step down the AC input voltage as the situation demands. Secondly, the transformer isolates the rectifier circuit from the power line and thus reduces the risk of electric shock. AC input of the rectifier will have both positive and negative cycles. Only one half of the input waveform reaches the output, hence it is only 50% efficient if used for power transfer. The half rectifier will allow only the positive half cycles and block the negative half cycles. During a positive half cycle, the diode allows current to flow from its anode to its cathode. Hence, the diode is said to be forward biased and will generate the positive half cycle of the AC. During negative half cycle, the diode is in reverse bias. In the reverse bias condition, the diode will block the current and no current will flow from the anode to the cathode. The voltage across the load resistance is also zero.
Power diodes can be connected together to form a full-wave rectifier that converts AC voltage into pulsating DC voltage for use in power supplies. The full-wave rectifier circuit produces an output voltage or current which is purely DC. Full-wave rectifiers have some advantages over half-wave rectifiers. Firstly, the average DC output voltage is higher than for the half-wave rectifier, and secondly, the output of the full-wave rectifiers has much less ripple than of the half-wave rectifier, producing a smoother output waveform. A full-wave rectifier center tap is more commonly used in DC power supplies than the half-wave rectifiers. The full-wave center tap rectifier is a circuit which converts an AC voltage into DC voltage using both half cycle of the applied AC voltage. The full-wave center tap rectifier uses two diodes, of which one conducts during one half cycle while the other conducts during the other half cycle of the applied AC voltage. It uses a transformer whose secondary coil is split equally into two halves with a common center tap connection. During the positive half cycle, diode D1 becomes forward biased and D2 becomes reverse biased. Hence, D1 conducts while D2 remains off. The load current flows through D1 and the voltage drop across RL will be equal to the input voltage. During the negative half cycle, diode D1 becomes reverse biased and D2 becomes forward biased. Hence, D1 is off and D2 conducts. The load current flows through D2 and the voltage drop across RL is equal to the input voltage. A bridge rectifier is another type of full-wave rectifier which uses a simple transformer without a center tap. It requires 4 diodes instead of 2 diodes for full-wave rectification. The 4 diodes are labeled D1, D2, D3 and D4 and are arranged in series pairs, with only 2 diodes conducting current during each half cycle. During the positive half cycle of the input, terminal M of the secondary coil is positive and N is negative. Diodes D1 and D2 become forward biased, while D3 and D4 are reverse biased. Hence, currents flow along points M, A, B, C, F and N, producing a voltage drop across RL. During the negative half cycle of the AC input, terminal N becomes positive and M is negative. Now, D3 and D4 are forward biased while D1 and D2 are reverse biased. Now the current flows along points N, F, A, B, C, E, and M ends. We find that currents keep flowing through the load resistance RL in the same direction.
Diodes are used as rectifier circuits to convert AC voltage to DC voltage. Rectifiers are used in all DC power supplies that operates using an AC voltage source. Rectifiers can be classified into three categories: half-wave rectifier, full-wave rectifier, and bridge rectifier. Half-wave rectifier use a single diode. Full-wave central tap rectifiers use two diodes and a central tap transformer, while full-wave bridge rectifier use four diodes with any central tap transformer.